Hello, I'm not Chuck. In a video a couple of weeks ago, I showed you my new camera panner. It's a device that, using a remote control, allows me to pan the camera. I can in fact rotate it 360 degrees by pushing a button on a standard television type remote control. I demonstrated that for you, and so I won't go through that again. I also promised you that I would give you another video explaining a little bit more about the internal workings of the camera panner. I realize that a lot of you don't really care, but maybe it'll be of interest to at least some of you. So I'm going to disassemble part of the panner, and I'll start by removing the set screw and taking the camera off of the panner motor shaft. This is a 3/32 inch hex wrench, sometimes called an Allen wrench, and it is used by inserting it inside a hex screw. This is a 3/16 inch screw, which takes a 3/32 inch wrench, and then the shaft will come out of the base of the camera mount. So that leaves us with the motor inside the box, the electronic controls inside the box, and the battery pack on the bottom of the box. I'll slip that battery pack open so you can see what that looks like on the inside. It's really not very complicated. It has 8 AA batteries, which taken in series make up a 12-volt battery pack. The on and off switch is right there. All right, put the cover back on and we'll go a little further. My next step is to take the top off the box. That is pretty easy. It takes removal of only 4 screws. These 4 screws at the corners of the box. The screws come out pretty easily. They are self-tapping screws, and when they're put in, they actually cut their own threads down into the corner posts on this ABS plastic box. So there are the 4 screws loose. I'll take those out, put them out of the way. I'll remove the power connector from the internals of the box. Opening up the box, you can see that the motor and gear train is mounted to the lid of the box. There are 2 sets of wires that go, one from the motor itself down to the printed circuit board inside the box, and another going from a set of dry contacts in the gear train going to another connector down inside the box. These are the 2 connectors I'm talking about. That one is from the gear train. I'll try to pull that one apart. This one goes to the actual electrical connectors on the motor itself, and I remove the whole motor and box top from the rest of the contraption. This shot shows the printed circuit board assembly remaining in the box after the motor and the gearbox have been removed and the leads unplugged from these 2 connectors. Notice that the printed circuit board is a fairly snug fit in the box. Cutouts have been made for the protrusions from the side of the box, and notice also that the 2 jacks, the power jack and the programming jack, are in between sets of protrusions on the box. That allows the jacks to be as close as possible to the exterior of the box. This is a shot of the printed circuit board assembly out of the box, and I'm going to explain to you what some of these parts are and what they do, but before I do, I want to show you what the bare printed circuit board looks like. As you'll notice, there are no components on the printed circuit board, but there is a lot of printing on it to show where the components are, to show that each component has its own number and to show the value of most of the components. These are what are called through-hole components. The reason that they're called that is because they have leads on them, and the leads go through holes that are in the printed circuit board. They're placed in the right position. The board is turned over. The leads are soldered onto these little silver circles, which are called pads, and then the rest of the leads are cut off. That process is repeated for almost all of the components on the printed circuit board. Now we go back to an assembled board. Every component is in place on the board, and I'll show you what some of the components do in very general terms. The power, which is 12 volts DC, comes in on this jack, and then it is filtered a little bit by this capacitor, and then it is regulated down to 5 volts by this component. It's filtered again, and then the 5 volts is passed to the microcontroller and some other components on the board for their use. This is an integrated circuit that is the IR or infrared signal receiver. It, along with a couple of capacitors and a few resistors and this transistor, are responsible for receiving the signals from the remote control. This transistor actually drives the blue LED, which flashes while signals are being received from the IR IC. This, as I told you, is the microcontroller. It is the brains of the whole printed circuit board. It is a programmable device. I wrote some code for this device telling it what I wanted to do. I uploaded that code through this programming jack to the microcontroller, and after some testing and some corrections, I now have it doing exactly what I want it to do. Now, I told you that these were all through-hole components, or almost all, but there is one exception, and it's right here. This component is what's called a surface mount component. It's very tiny, but it is soldered to the printed circuit board to the top side. There are no holes for it to mount to, which makes it quite difficult to hand solder. I've had some practice with it, so I can do them reasonably well, but they're hard to handle because of their size and because of the soldering is done on the top of the printed circuit board. This particular component is actually what's called an H-bridge, which is the integrated circuit that controls the motor itself. It switches 12 volts DC on and off to the motor, and also switches polarity to make the motor run backwards or forwards as dictated by the integrated circuit. These are header pins, these 9 and these 5, and they are there for future expansion and future options that I may add to the circuitry. One of which I hope to add in the near future is a tilt control. So not only can I pan the camera right to left, I'll be able to tilt it up and down. That is not yet finished, but hopefully will appear in a future version, which will then be called a panner tilt control for the camera. So that's about all the detail, I guess, that I want to go into at this point. I thank you for watching. I thank you for subscribing. I thank you for your comments and your questions. If you have any, please post them below. Thanks very much. And don't forget, I'm not Chuck.